New research shows that persistently pumping groundwater has shifted Earth's axis. The reason is that we're moving all that water mass from under the continents to the oceans. Most groundwater ends up in our oceans and raised sea levels by 6.24 mm from 1993 to 2010. Below the Earth's surface lies over 1,000 times more water than all the rivers and lakes in the world. This groundwater accounts for almost all the fresh water on the planet, but in many areas of the world, groundwater is being extracted faster than the rate that it naturally recharges. A recent study found that humans are pumping so much groundwater that it's not only increasing sea levels, it's actually shifting the entire planet on its axis. How groundwater depletion affects Earth's rotational pole. The Earth's rotational pole normally changes and wanders by about several meters each year. Many factors contribute to this axial wobble, including the melting of snow and ice in the northern hemisphere every spring, which significantly changes the distribution of water mass on Earth. Extracting groundwater also redistributes water mass. Groundwater naturally exists under continents, but about 80% finds its way to the ocean through rivers after extraction, therefore shifting all that water mass from Earth's continents to its oceans. And we've been extracting so much groundwater that it caused the Earth's rotational pole to drift by 64.16 degrees east at about 4.36 centimeters per year from 1993 to 2010. Researchers reported in the journal Geophysical Research Letters in June. For comparison, a different study reported that the accelerated melting of the glaciers drove a polar drift of 26 degrees east at about 3.8 milliarc seconds, or about 9.84 centimeters per year, after the 1990s. Since Earth's rotational pole periodically wanders by several meters per year, this contribution of a few centimeters from groundwater depletion is unconcerning. One of the researchers told Insider, "What we found in this study about drift of the pole would be negligible compared with such several meters oscillations, so at this point, we wouldn't worry about it," said Ki Weonco, geophysicist and associate professor in the Department of Earth Science Education at Seoul National University, who led the study. He added that the rotational pole returns to previous positions most of the time. What is concerning, however, is groundwater's contribution to sea level rise. Why humans pump so much groundwater, and its negative effects on the Earth. Groundwater is used for about 40% of global irrigation, and provides almost half of all drinking water. Extracting it unsustainably may threaten aquatic ecosystems, cause water scarcity, and increase sea levels. To put it simply, groundwater depletion contributes to sea level rise because water is being transferred from the continents to the oceans. The recent study found that groundwater depletion caused a 6.24 millimeter rise in global sea level from 1993 to 2010. This is significant because each millimeter rise in sea level is said to make the shoreline retreat an average of 1.5 meters. Pumping too much groundwater too quickly can also decrease water flow from natural streams. Another study found groundwater naturally feeds into streams, but when groundwater levels drop due to human extraction, it can reduce or even stop stream flow altogether. In turn, this threatens the many ecosystems that rely on water flow both in and around streams. Without better management, an estimated 40% to 79% of all watersheds that pump groundwater may no longer be able to maintain healthy ecosystems by 2050.